Okay, so we've seen some basic examples of loops that produce stars, not very interesting. It is worth thinking at this point about where in our previous code, the previous topics we've looked at, where could we use loops? And actually, some of those examples we looked at already are natural candidates for loops. So, for example, the random number generator uses 4 identical lines of code to generate 4 random numbers. Really, you should be doing that with a for loop. Okay, and we've also seen programs where we ask the user for some input and then we make a decision, maybe what concessions they get or something like that, what their year of birth is. Again, those could be done with a while loop, so that once we've asked one user, we can ask the next user. It's more like the cash machine example. So we want to do the same questions over and over again, and then make the same decisions over and over again. But we don't want the program just to run once. It's a bit annoying to have to run the program every single time to get to work out the concession. Okay, so the random values. there's the code. Going back to lecture 2. This is the code that generates 4 random numbers. Okay, trouble is that's only going to produce 4 random values. And actually, we've seen now, if we've got a loop, we can decide as the loop runs, at the point when the loop runs, how many times we want it to run. So if we want to, excuse me, if we wanted 20 random values, to use the code in this way, to use this same kind of code to produce 20 random values, we'd have to add another 16 lines of code. If we do it with a loop, we don't have to do anything like that. So this is the way of doing that. Okay. So here I've got a question for the user. How many randoms do you want? So I ask that question, prompt them for an answer, and then convert whatever number they give me into an integer. And then in this case, there's various ways of doing this, but I'm using the output string where I just add whatever the next random is onto the end. So, okay, here we are. The counter runs for that number of randoms, and then the output string we just add on a space, because we want a space between what the previous random and the next one. Then we generate a random number between their maximum and minimums that they've told us previously, and we convert that into a string. So you could use f-string formatting here, or here we're using the string function to convert that into a string. So that gets added onto the end of the output string, and then when the loop has calculated all those random numbers, we print them out. So actually, let's run that one. 7, here it is. Here's the code. So if I run this, let's have numbers between 1 and 10. And for this 4 lines of code, I could have 200 of them. I could have 2,000. There they are, 200 numbers. So it's calculated 200 numbers between 200 random numbers between 1 and 10, and it'll just run. It asks us what the number is. It'll run for that number of iterations. So we often, I don't know if I've used that word, but we often use iteration for saying how many times something runs. And here actually I've done this slightly differently to the lecture notes. I've converted that into an F string. So I'm adding an F string with the random calculated, but the same idea. Okay, so that gives me the random one. In lecture 3, we saw the concessions calculator. So we worked out what concessions people were entitled to in this example of code. Okay, the annoying thing, and somebody actually asked me about this, what happens if you type in something wrong? Well, you just have to run the program again in this example. But it's much more sensible to have a loop which will allow you to keep repeating this set of questions, and then if you get it wrong, you just go to the next time around the loop and enter your questions, and it can just keep going forever. So we don't want to run this code over and over again, because we might have lots of people where they're asking for this might be a ticket machine or something where people are trying to get some tickets, and it's telling them what discount they're entitled to. So what we would normally do, if we want to convert that into a sort of an infinite loop that repeatedly asks the same questions, we take the main part of the program and put it in a while loop. So we take that main part of the program, all this code here that you can see, where we ask them their name, all that stuff, put it in a while loop. You could run the while loop indefinitely, so it could just run and run and run until you kill the code from PyCharm. But it's even better to provide a way of the user executing the loop without having to kill the program. So a good way to do this is if the loop ends when no input is provided. So when I say when the loop asks me what is your name and I put nothing in, then the loop ends. That's the way you would normally expect something like this to run. So the logic of the program is something like this, and often when you're trying to figure out these things, you write out some what's called pseudocode. So it's not really code. It's kind of a bit like code, but it's more English. Python doesn't understand it, but it gives us a way of thinking about the program. So what do? We prompt the user for their name. While the name contains some input, okay, that's the key thing. So it only runs while the name contains input. If there's nothing in, if the user hasn't input anything, then the loop stops. We prompt for their status and their age, whether they're a student, that is, and their age, and we calculate the concession, and then we prompt the user for their name again. So we have to prompt again so that when it goes back to the top of the loop, remember it's this looping round and round and round this bit of code. When it gets back to the top, it checks, and if there's no input, then the loop terminates. As I said, this is known as pseudocode. It's a bit like code to help us understand the logic, but it's not code because a computer wouldn't understand it. So if we do that example, here's the asking the user for their name, and while the name is not empty, so while it's not an empty string, then we have to work out the concession. Well, that's exactly the same code as before, except that it's indented, so there's no changes there. And then we print the message, and then we ask them what their name is again, and that will then take us on to the next round the loop, or maybe it won't if they haven't put anything in. Let's just run that one. So here it is. So there you can see the 2 lines at the top where we ask them their name. Here's the code. This code here is exactly the same as before. So for calculating the concession and printing it out, and then we ask them for their name again. So if I run this, ask for my name, just put something random in. Are you a student? Yes. How old am I? Let's say 20. So I get a 10% discount. And then it asks my name again. So I put a name. Are you a student? No. How old are you? Let's say I'm 7. Okay, again, I get a 10% discount. So this is a really good way of checking every possibility as well, whether all possibilities are working. Can I get myself 20% discount? Well, I have to be a student, and I have to be under 18 or over 65. Let's make me 66. And then I get my 20% discount. And then if I put nothing in, remember down at the bottom here, when it asks what is your name, if you put in nothing, when it goes back to the top of the loop only runs while the name is not equal to nothing, when it's not an empty string. So if I just put nothing there, the loop finishes. Okay, so that's a way of converting that code into a useful repeated operation that will keep running forever. There's no stopping it until somebody doesn't enter their name. Okay, I'm going to finish there, and then we'll look at some more loop controls.